Hello class, this is the distributive law continued. We already know from the previous video that if we have the expression, let's just take for example 3xy to the power of 3 in a bracket like that. We know that that index 3 distributes to each of the numbers in the bracket. So it's going to be 3 to the power of 3, x to the power of 3, y to the power of 3, 3 to the power of 3 is equal to 27, x cubed, y cubed. So we already know that. But what this video is if we have the expression, let's take for example a over b to the power of n. So we have some expression like this. Well, the distributive law applies exactly the same. It'll apply to each one individually. So it will become a to the power of n over b to the power of n. So continuing on from this idea, just as we saw that there's multiple expressions in the bracket that this indice distributes to, this idea applies to this one as well. Watch what I mean. So let's take the expression 3a over 2b all to the power of 2. Well, this indice will distribute to each one individually. So it's going to become 3 squared a squared 2 squared, all over 2 squared b squared, which becomes, well, 3 squared is 9a squared over 2 squared is 4b squared. Let's take another example. We'll get a little bit more complex now. Here we go. We'll get 3 a squared b cubed all over 4 x to the power of 4 y to the power of 2. All of this to the power of, we'll make it 4. Now the distributive law, once again, that 4 will distribute to each one individually. But if you take note, there is a multiplicative law in action as well. Because remember, I'll do it in black here on the side. From the previous video, if we had x to the power of m outside the bracket of n, it becomes x m times n, which is x m n. Or with numbers, by the way, this is just reminding you of what the multiplicative law was, just really quickly. X to the power of 2 outside to the power of 3. It'll be x 2 times 3 x 6. So we're going to use this idea, the multiplicative law, alongside the distributive law in this big expression here. Okay, so let's take a look here. Ready? we now have this is equal to 3 to the power of 4, a to the power of 2 times 4, b to the power of 3 times 4, all over 4 to the power of 4, x to the power of 4 times 4, and y to the power of 2 times 4. There's a lot going on here, but let's just keep at it. 3 to the power of 4 is 81. A to the power of 2 times 4 is a to the power of 8. B to the power of 3 times 4 is b to the power of 12, all over 4 to the power of 4, I don't know, 4 to the power of 4 is 256. 256. X to the power of 4 times 4, well, that's x to the power of 16. And y to the power of 2 times 4, well, that's y to the power of 8. That was a handful. Let's try one more, and let's get a little bit more complex now. Let's take the idea of, let's go with 2 x to the power of 3, y to the power of 2, all over 4 to the power of x squared, y to the power of 3. Whoops, sorry, we'll make that y to the power, we'll make this y to the power of 4. We're moving into a topic that we're not quite ready for, and then we'll make this not too hard, to the power of 2. Now let's work on this at one step at a time. Distributing, that'll be 2 to the power of 2. That'll be x 3 to the power of 2, 3 times 2, so it's 3 times 2. Y 4 times 2, all over, well, that's 4 squared, x 2 times 2, y 3 times 2, two squared is 4, x 3 times 2 is x to the power of 6, and this one here is y 4 times 2 is 8, 4 squared is 16, x 2 times 2, this one here, is x to the power of 4, and y to the power of 3 times 2 is y to the power of 6. Now, here's where it gets really complicated. We're going to use what we remember from fractions. What is 4 over 16? Well, that's the same as, well, we'll do it in black now. Well, we can divide both of them by 4. So we can divide this by 4 and divide this one by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. Now take a look here. Do we remember from the adding and subtracting of indices? Isn't this x to the power of 4 divided by, x to the power of 6 divided by x to the power of 4? Wouldn't that be 6 minus 4? So wouldn't this only leave us with x squared, because it's 6 minus 4. Same with this one. This becomes y 8 divided by y to the power of 6. So that is 8 minus 6. So that goes away. And we're left with y to the power of 2. So take a look. In black, we have a 1. But we don't need to write that. X squared, y squared. So we're left with x squared, y squared on the top. All over. Well, this has been cancelled out. This has been cancelled out. And we're left with a 4. And if you're wondering where that 1 went, well, there's a 1 here. But in mathematics, we don't write 1 as a pronumeral for these. Sorry, as a coefficient. We don't put 1 as a coefficient for this. That there is a very difficult idea. Don't worry, I'll get you to practice that soon.